Okay, here are notes for geometry, geotrig 3.2. So let's put that up here in the top corner. There you go. All right. And these are on translations. This is a translation in geometry simply means moving. We often use the word sliding. You don't rotate, resize, or anything else. You just move it. Okay, it's just moving. To translate a shape, move every point of the shape, or every point of the shape must move in the same direction in the same distance. Same distance, same direction. So if you took this little faded out triangle and you slid it up, all of the points would move the exact same direction and the exact same distance. So that's what it is there. Oh, I forgot our comic for the day. Here we go. It's Foxtrot, my favorites. And here's Paige complaining. She says, "Why do they make us study math in school? I hate it." Not now, Paige. I'm trying to think. It's not like I'm planning to go into astrophysics or something. I need to cut this quiche into 5 equal pieces. Give me one example where I'm ever going to use this junk I'm learning in geometry class. Just one. Let's see. A fifth of a circle is... And Paige says, "Just cut it into 72-degree wedges and listen to me, Mother." Oh, thanks. And she thinks about it, says, "Okay, fine. Give me 2 examples," because she just used it, what she was doing. Oh, wait. Peter wanted his slice twice as big as the others, so she could use it again. All right. Sorry, that was just funny. I like those. All right, so moving on. This is what you should be looking at on the Math is Fun website. You should definitely open up a new tab and go to this little picture here. Now you are actually going to draw something on this picture on your notes. We're going to translate it 40 at a 40-degree angle at a distance of 100, and we're going to see what that looks like. And then we're going to translate the same one at where x is going to move 40 and y is going to move 50, and then you're going to draw that one as well. All right, so if you could go to that website, you should. You should play with it a little bit. And so let's let this come up for a second. mathisfun.com. See the little thing here. I'm going to click on the red triangle first. Puts it right in the middle. And I'm going to change the angle to 40. And I change the distance to 100. And then I'm going to hit translate. And you're going to see where it's going to go. Notice that they're all going 100 and they're all going 40 at a 40-degree angle from horizontal. So if I was to make a horizontal angle from this point right here this way up to that point, that would be a 40-degree angle. It moved it up 40-degree angle and it's moved it a distance of 100. Now if I was to change my thing here and use x as 40 and y as 50, and I need to put the triangle back in the center again, and then I'm going to move it, and it's going to show you it's going to go over 40 up 50, over 40 up 50, over 40 up 50. It's going to shift it that way. So that's a different angle. This time we moved it by an XY coordinate, which is most of the time what we do in translations. Almost every time we're going to translate it with an X and Y value. Rarely do we do it at an angle. Now it can be done, like we said, you can draw horizontal and draw an angle, a 40-degree angle, and you can slide it as whatever distance you want. Normally we're going to translate things at an X and Y coordinate. So hopefully you drew those on there. You can see where what the 40 and the 100 would look like, what the 40 and the 50 would look like. You might just draw one of them and just look at the other one on the website. But I'm going to move on so you guys can hopefully play with that a little bit, because the next slide also has that on there. I wanted you to look at this shape as well. I wanted you to put in your own angle and distance, and I wanted you to put in your own X and Y. So maybe if you went to this one, you drew, then you put that shape there. Maybe you did like a 90-degree angle. Now 90-degree angle makes an L, so it should bring it straight up. Maybe you want to do it at 50 instead of 100. So this would translate it straight up. 90-degree angles are straight up. So each one's going to go up 50. So each point moves up 50, and so each one of these little lines is probably 10 or something. So that would be translating it up 90-degree angle at 50. So anything in anything where the shape's going to go this way is acute. If it went over this way, it would be obtuse. If you went down this way, you'd have in a reflex angle. So that would be the angle. Now, if you translated it, let's say you went over 30 and up, like 70 or something, and then you hit translate on this one, it'll translate it over 30 and up 70. Everything's going to go over 30 and up 70. Every single point, up over 30 and up 70. Over 30, up 70. Over 30, up 70. This one will go over 30 and up 70. So that's translation there. Just sliding the figure a certain amount. Usually we use X, Y coordinates. So put in your own angle, so something different, and draw the translation on your notes. See what it comes out to be, because it's going to show it to you. If you just put it in and draw it, it'll show it to you. Now, let's say you don't have, a way to go to this website or whatever. You can actually put in your own X and Y and count over 30 up 70 and make a dot, or over 20 and up 60 if you want to do 20 and 60. You can even put negatives in. Actually, we should do that. Let's put negative 30 and translate it, and you're going to, oops, my bad. Hold on, let's start over. It's going to run this little course there. Okay, so let's go back to here, put negative 30, so you can see from that original shape, this time it's going to go left and up. It's going to go to the left for X and to up for Y. So that's going to be going in this direction, negative X and a positive Y direction. Alright, so let's take a look at a few examples of that. First, let's look at how we actually write it down, our notation that we would use. When we want to say that a shape gets moved 30 units in the X direction and 40 units in the Y direction, so if you're going over 30 and up 40, here's how you would write it. You'd put your X, Y, and you'd put X is plus 30 and Y is plus 40. It just means to get to your image, you need to add 30 to the X and you need to add 40 to the Y to get to your actual image. This was the pre-image down here. To get to your actual image, you go over 30 and up 40 on all your coordinates, which says all the X and Y coordinates will become X plus 30 and Y plus 40. So again, it's like a function. You're dropping in the coordinates that you have, and you're adding 30 and adding 40 and getting a new coordinate. This new coordinate would be from here to here would be 30 to the X and 40 to the Y, and you would get the new point. So again, this is like writing our rule right here. This is a rule for our translation. Let's look at it another way, another notation that you can use. So we have this symbol right here could also be used as a vector symbol. Now, a vector is what we use to move a translation. A vector is the direction that the translation goes. So this translation is going to go over 8 and up 4. That's called component form. This is what the vector would look like on your graph. Here's point P and here's point P prime. This was your pre-image. This was your image where it ended up. Okay, so this vector went over 8 and up 4. So that would be the vector in component form. In coordinate notation, you would put my XY increased by, my X increased by 8 and my Y increased by 4 to get to my new point. Here it's just telling me go over 8 and up 4 to get to your new point. That's called component form. This is called coordinate notation. And this little symbol is a vector symbol. Vectors tell us exactly how far things move and how big it is and stuff like that. Okay, moving on to the next one. Okay, we just have a few examples. Now you do need to stay tuned in the video because there are 2 extra credit opportunities at the end. So you do want to make sure you finish the examples, get to the end, and watch and see the 2 extra credit opportunities, because those you have to turn in tomorrow if you want the points for those. So this says graph the image of the rectangle BCDE after its translation 4 units to the right and 11 units down. So first thing we want to do is go 4 units to the right. So we want to add 4 to my X. Okay, so I want to put X plus 4 in here. But I want to add 4 to my X, and then I want to add 11 down. So that's going to actually be Y minus 11. You're going to take 11 away from the Y value. My thing is still not big enough. Okay, so So you went x plus 4, and you're going to do y minus 11. So squeeze that into your little rule. This is our translation rule right here. So what that's telling me is I can find my 4 new points without even graphing it if I want to. I can automatically put in, I'm going to add 4 to the x, so negative 6 plus 4 is going to be 2. Actually, let me put it up here. And my, oops, I'll put it in here. It's going to be a 2. And my subtracting 11 is going to put me at negative 7, or my y value, so 2, negative 7. So I could go to that point on my graph. So I'm going to go over 2. I'm sorry, it's negative 2. So negative 2, negative 7 is right here. Fix that. You guys probably already knew that, didn't you? Okay, so it's if I add 4 to negative 6, I'm going to stay at negative 2. When I subtract 11 from 4, I'm going to get negative 7. So negative 2, negative 7. So that would be point B, or B prime. So B prime is down here. Okay, so I went over 4. 1, 2, 3, 4. And I went down 11. 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. Boom, right on B prime. So, I mean, I could count the rest of them over 4 and down 11 and make my dots, but I also know I can just do that in here and get the coordinates. Let me, this one's going to go, that was point B, right? So E is going to be one above it, E prime, right there. And then D prime is going to be over, let's see, over 7. 5, 6, 7. We're going to test our rule and see if it's working. And this one will be down 1. So my new shape, I drew that in. It's not perfect, sorry guys, not good enough. Let's make it white or something. We could actually make it clear. Let's do that really quick. Okay, so you could see that this point right here, where let's say D is, D prime should be the point 5, negative 6. Let's use our rule and see if that worked. If we take x and add 4 to it, it is going to give us 5. So that's correct there. If we take 5 and subtract 11, you are going to get negative 6. So that does work there as well. So 5, negative 6, C prime. If you add 4, you're going to get a 5. And you subtract 11, you're going to get negative 7. So that's 5, negative 7. So that's this point way down here, C prime. And then you've got D prime right here. And B prime was down here, so this is going to be E prime up top. Right over my points, sorry about that. That would be a translation, 4 units to the right and 11 units down. And that was our rule. E down here we know, or E prime we know is the point negative 2, negative 6. So negative 2. And negative 6. There you go. Alright, so let's look at the next one. Graph the image translation 6 units up. So it's not giving us any new x. So you can just say you're going to stay with your x. X is not going to change. Your y is going to go up, so it's going to be y plus 9. So it's just going 6 units straight up. So let's see, if we kept our x value, we would still have 9. 8's going to stay at negative 8. And U prime, 9 is going to stay also. going to stay at -2. And our v is going to stay at 5. And our our y value is going to add 9 to it. So -4. Oh, I forgot to add 9 to these other ones. I'll do that in a second. -4 plus 9 is going to be a 5. Okay, so let's go back to this path right here. -2 plus 9. -2 plus 9 is going to be 7. And then, let's see. -8 plus 9 is going to be 1. Okay, so the y's changed, the x's did not. The x's stayed the same because you're not going over at all, you're just going up. So if we were to graph those 3 points, let's see, 9, 9, 1, and 9, 7, and 5, 5, that would be the triangle that we would want. That would be the triangle. That would be a translation 9 units straight up. So that's what a translation in that case is. This is our translation rule right here. We're telling us to move up 9 units. Don't change the x, just add 9 to the y's, and you'll go straight up. Again, you can pause the video if you need to. Okay, so here's a different one. Let's see if we can find our coordinate notation this time. We want to go 7 units left and 5 units up. So 7 units left. So for us, that's going to be x minus 7, right? Because left is negative. 7 units left. 5 units up would be 5 units positive. Y plus 5. Okay, so 7 units left, 5 units up. So let's find the points first. So the first point we would do is, if we go 7 units left, if we take 7, subtract 2 minus 7, you're going to get a -5. So -5 is going in there. And then -4 plus 5 is going to be a 1. So you're going to have a 1 in that box. So -5, 1 would be one of our points. Let's make a dot at -5. 1, 2, 3, 4, -5, 1. Now let's test that. Supposedly, that doesn't look quite right yet. Okay, it might be. It's D prime. So D, we want to move 7 left and 5 up. So let's see if that's what we did for D. 1, 2, 4, 5, 6, 7. 1, 2, 3, 4, 5. Good. So this would definitely be D prime right here. That is our image to D. That's where D is going to move. D is going to move up to here. It's over this 7 and up 5. So let's see. E, if we go over 7, we subtract 7. 5 minus 7 is going to be -2. And -4 plus 5 is going to be a 1. And then F prime, 5 minus 7 is also going to be a -2. And 1 plus 5 is going to be 6. And then G prime, 2 minus 7 is going to be a -5 again. And then 1 plus 5 is going to be 6 again. Okay, so those would be our coordinates. Now let's make our dots and see if the figure looks correct here. So we got the first one, -2, 1. What we want next, so -2, 1. Okay, then we want -2, 6. So I move 6 to there. And then we want -5, 6. Okay, right there. And that looks perfect. I think it's going to look just where it's supposed to go. That doesn't look perfect. The shape's a little off. It's okay. That's your coordinate notation. Those are the points. You can use your coordinate notation to fill in the points and then draw the pictures, or just get the points out like there. It's a little formula. All right, there's one last theorem that you need to learn in this section. It's called the double reflection theorem. Basically what that is an image created by two successive reflections. Now, reflection is what we did last time. We flipped it. But if you flip it around two parallel lines, your answer is going to become a translation. The magnitude of the translation vector, magnitude is distance, so magnitude means how far it goes. The magnitude of the translation is twice the distance between the parallel lines. So if you found this distance between these two parallel lines and then doubled it, that's how far you moved this one over to this one. So the double reflection theorem for a translation is used to create a translation of triangle DEF. So here was our original triangle. We flipped it and got this, and we flipped it again and got this. If you had just drug this one all the way over here, it would have been the same triangle. That's what they're saying. If you flip it over parallel lines, you're going to get the same triangle. Okay, so you try it. So what I want you to do is pause the video, draw a line at -3 for x equals -3 would be straight down, and x equals -3. Then draw a line at 4, and then flip them both and see if it comes out. See if it's a actual translation. Pause the video and then try it on your own. See what happens. Come on, pause the video, try it on your own. You guys know you need to do that. All right, here we go. Hopefully you paused it. Here's what you should have gotten on your paper. You flip the first one, you get to this point. This is, remember, for reflections, this is two-way, so this would be two-way. This is two-way, so this one will be two-way, and this one's, like 5 or 6 away. So you flip that over, then you flip it over again, and if you look at it, I could have taken this triangle and slid it over here, and it would have been a translation. It would have been straight over horizontally, however many units to the right. So that would have been a translation. Oops, my bad. So this triangle right here, can't get it now. Oh well. This triangle got translated. When you flipped it twice, it actually got translated. So if you try it here again, if you flip this one and then flip it again, you'll see that this flipping here, you'll get to this one, and then you flip it again, you get to this one. It's only when you flip it over parallel lines, now you can see that this triangle would be the same here. These two triangles would be a translation, where you just brought it straight down. So when you do this, you notice that it's a translation of the original. Slide the top triangle down and it will match up with the one on the bottom. So that's what you see there. If you flip this one twice, it's going to get right back to where it started. It's just going to be down a little farther. All right, you guys, here are your 2 extra credit opportunities. You can try them, see what you can do. You need to tell me what the measure of angle D is right here if you want to get this one. Make sure your name is on your paper. You put a small piece of paper, put your name on it, put it in my little bucket tomorrow, and you can get angle D. This will be tomorrow, Friday. Don't put it in today if you watch it early. Put it in tomorrow, Friday. And then 92% fail at this simple test. You just need to count how many squares there are here. If you can get the right number of squares, you get extra credit. So good luck, and hopefully you guys give that a try. And we'll see you guys later.